going to share my screen. So one of the things that I always recommend is when you learn any new concept, I don't care if it's arrays, linked list, doubly linked list, red, black trees, mini-max, whatever. The first time you hear about it, do yourself a favor. Make a single program that does nothing but play with that new concept before you try to integrate it into a larger project. Because as soon as you integrate that into whatever the big assignment is, A, you're not taking the time to understand that concept the way you should, and that's one of the most important things that you need to do is understand these concepts. Either learn them now or you learn them later, right? B, it doesn't help you in the efficiency in finishing the program in a short amount of time. Because you're going to be fumbling over how do I integrate it into the bigger project, right? And I don't even fully understand what I just learned. So do yourself a favor and always do that. So before we introduce the bigger project, we're going to create a smaller just program that does nothing but experiment with this stuff. So I call this. Anybody ever used this before? No? Good. Did you use Swing? Anybody use Swing? Anybody use any graphics packages ever? No? Oh, okay. I'm going to go ahead and I'm going to come in and I'm going to label things out. Give myself some space because I know that all of the code goes in here. And we're going to get started up at the top here. So the first thing I need to do is import my library to help me. And again, that's going to be the AWT. So I'm going to say import java.awt.star. I want everything from that particular package. Oops, didn't mean to do that. Then I'm going to come down and I'm going to start setting up my overall project. So the first thing I need to do is I need to instantiate a frame object. So I need to come in and I need to set it up. So I need a new object of type frame. Notice how I'm wording this as I go through. It's going to be an object of type frame called F. I could make that any identifier I wanted. I'm going to call it F for frame. And then I want to set that equal to new frame. And then this is where I label that frame. So whatever I put in here is going to show up in my title bar right here. So you can put like your name, first AWT or something like that. So I want to put Mike's first frame. Neighbors help neighbors as you move through. I am recording this. I'll put it up, share with you, right? The next thing we're going to do is we're going to set the size. So we're going to say F, because that's the name of the frame, dot. And then I'm going to say set size. And we're going to put it at 500, 500. Remember, that's in pixels. The last thing we're going to do, it's going to seem a little bit odd at first, but I'll explain the purpose. We have to set this to be visible. We want to see it. So we're going to say f.setVisible, and we're going to set that to true. Yeah, that's going to make it visible. So first thing we did is we instantiated our object of type frame. The next thing we did is we created the frame. And the last thing we did was we made sure it was visible. I know that sounds kind of odd, but there's actually a lot of frames that fire off behind the scenes that are invisible. You don't see them. They're doing something. Maybe they need to take a capture or something like that, but they're invisible. But we want to make this particular frame visible. I want you to go ahead and run it at this point. But listen, don't try to close the frame without listening to me. So go ahead and run it. And you should have your first frame. Do not click this button. Now I'll explain why. Don't click it. You want to stop the program with your console. So hold on, let me get my console up. You want to make sure down here you click on stop. You want to click on terminate. Because when you close it, if you just close this frame, all you're actually doing is closing that window. You're closing that frame. You're not closing the program. The program is actually still running. Remember, we made the frame visible. So when you close it, the program overall is still running because we haven't put any code in that says if the frame becomes invisible, kill off the program. And we're not even going to do that. Everybody good? So you're always going to close it right there. So that's the basics. So the next thing we're going to do is we're going to set ourselves up to actually draw some graphics here. So I want to say graphics, G. Graphics is a data type. It's an object data type that comes from the AWT. It's kind of like when you say int or float or double or whatever. It's data type graphics. Bless you. We couldn't use graphics if we had not imported the java.awt. So the next thing we're going to do is we're going to say G equals. So we're going to connect our graphics to our frame. We're going to say where we want to draw stuff. G, that's an identifier, equals f.getGraphics. Okay? Go to Window, and then go to Show View. Yep, that should take care of it. There you go. Yep, and then hit the stop there. Now what will happen is on your computer, if you forget to hit that stop on the console, it'll take about 20 runs and your computer will start slowing down. AWT is just not a very efficient program. On your computer, you can hit Control-Alt-Delete and actually kill those processes off if you want. On these computers, you can't do that. You can't hit Control Delete on these computers. Well, you can hit it, but you can't bring up the process. Yep. Mm-hmm. Yeah. Good. All right. So we've put the tie together. So if we wanted, we could have two different graphics, right? We could have a different graphics. We could have two different frames if we wanted. Maybe we wanted one called F1, F2, F3. We have tied G to F. That's what we've done with that last line. So now let's draw something in the F frame. So I want to say G dot draw line. And there it tells me all about it. X sub 1, Y sub 1, X sub 2, Y sub 2 is what it's looking for. So I'm going to draw exactly what I put up there. I want it to go from 0, 0 to 500, 500. Then I'm going to run it. And when I run it, it's going to draw the line for me. Did you see it? No. Try it again. Hit stop and run it again. Did you see it draw? I'm not messing with you. It drew. No, it's a black line. It draws it. No. There is something going on. And you're digging at it. Did you see it? It's just a flat. You're on an Apple. It might just kind of hold there. Is it holding there? Yeah. On the Windows, it doesn't do that. How can we get it to hold the line? What's going on? How many times have we told it to draw in the frame? Once. How many times per second, gamers, is your window updating itself? 60. It's actually 60. We're running at 60 hertz, right? 60 times per second. So that line got drawn in 1/60th of a second, and on these computers, it's so fast you can't see it at all. On the older computers, you used to actually be able to see it for a second because there was a delay, right? But now computers are so fast you can't really see it. For some reason on Macs, it holds it. I don't know why, but it does. So now we introduce the idea of a frame buffer for those of you that like to play your games. We have to set it up so that it consistently draws onto the frame over and over. So how do we do that? What do we do? No. How do we do it? We have a mechanism. How do we redraw the frame and what we want on the frame over and over? A loop. Let's put in a loop. Don't forget to hit stop. All right? Now we need to decide what we're going to loop. We're going to loop the body of what we want to draw. Nothing else. We don't need to reinstantiate the frame. We don't need to initialize the graphics G anymore. We just need to draw over and over. So we're going to say while give me 1 second. I got to put another variable in here. A couple other things here. Walk with me. We need to import scanner now. That'll import all the scanner. Then we need to put in, we'll say double response equals 0. So that's going to start setting up our loop. And then we're going to say scanner INP for input equals new scanner system.in. Not doing anything that you haven't seen before. So I want to come down and I want to say while response is less than 10,000. Perform the body of my loop. Now I need to put in here, I need to increment response. So I'm going to increment that. Type 1 to exit. Bless you. I'm going to go ahead and run it, and then I'll come around and help. So now I see my line constantly drawing. And if I hit 1, now it exits for me. By the way, you still can't close it over here. If you do close it, notice the process will still be running. You still got to hit 1, and that'll close it off. Cassidy, you good? You need to be actively thinking about what is going on as we're learning this stuff. Don't be a lemming. Don't follow me off of a cliff. What you need?
Can you like put comments on what you just did so I can understand it better?
I'm going to run it. Theoretically, it should stop drawing after it hits 10,000. This 10,000 loops, we don't have it set up, so it's just 10,000 loops. So however long that's going to be. Theoretically, we could say that 1 second is 1 loop, but it's moving much faster than that. So however long it takes to draw that frame. Yeah, so we could say 60 frames per second. It could be one way to look at it is, say, 10,000 divided by 60. That'll give you how many seconds. Theoretically, you can test it out. But since we aren't actually saying hold that state for X amount of seconds, it's all relevant to the speed of the computer. Does that make sense? Yep, Drew.
No, just looking at a comparison of yours and mine, I don't know if it's just a thing done by the screen sharing software or whatever, but
It may be.
shows a little bit of distortion surrounding your line.
Like that's probably some artifacting that's going on, because what they actually do in the screen capturing software is it's a video, it's a recorder, it's a camera, and they're just kind of broadcasting it. I might be able to clear that up a little bit. that make it any better? Yes, no? Did it? Cool. Let me see where it was at. Roland, that's a kill switch. The system.exit, that's a kill switch. Kill off this process.
Okay.
You know what this is. This is the... Did I get it all? Is that everything?
Yeah. So for the system, like for the system to like exit, like how to like put the kill switch into action?
Well, as soon as you, it's this is what's going on is it's pausing, waiting. So as soon as I hit 1, it just goes on to the next step.
It goes to the next step.
Yeah. So right now it's paused, waiting for user interaction. It's still in that loop drawing because we told that frame to keep drawing, but then it went on and now it's paused, waiting for me to put something in. As soon as I put something in, here,
So anything
it kills it.
can exit.
Yep.
Even it's specified.
Yep.
On your line for the system.exit, why do you have 0 in parentheses?
That's the state that we want it to be. Exit 0 as in false, so kill it off.
So if you said 1, it would just keep going.
We'll have to look up the exit states, but that would be my guess. I don't know. I'd have to look up the different states of exit. And I'll play. Nope, that killed it too. I don't know, dude. Good question. Maybe I just have to supply something to it. To the exit method there. All right, so let's play it a little bit now. I want to move my response down a little bit, and let's experiment and see if we can draw that circle, okay, that I have there, and see if it works the way that I thought. So I want to say G dot draw, and notice it brings up the different things, and I want to draw oval. And it's going to ask me for X and Y, width and height. So 250, 250, 250, 250. Run it. And there we go. It's exactly where we thought it would be. Chopped off a little bit over there in the corner for some reason, but that's okay. I'm not sure why. Let's try another one. Let's try putting a rectangle in the upper left-hand corner. Or a square, whatever you want. I want to put a filled rectangle up there. I think, see, 25, let me see, I want to go X, 0, bring it down 25, because I think that's the width of that title bar. I'll say 100, 100. See what that does. Yeah, that looks, whoops, that looks just about right. Try that again. I did something funky there. You know what, Roland?
Yeah.
It goes through it really quick. See, look, it's not redrawing that frame anymore. So let me put something crazy in there. So theoretically, I should be able to do this if I can get it. And yep, see how it's still redrawn? And once it hits whatever number I put in there, like a million or a billion or whatever I put, then it'll stop refreshing that. So if we look at the task manager, this is always the fun stuff to me. Look at that, it's running at 38%. I guarantee you that's that frame drawing. I told you AWT is not a very efficient way to draw things. And as soon as it hits that counting-wise, I put like 100 million or something in there, it'll stop. Let me bring that down a little bit. Let's try it now. So notice my CPU dropped back down. As soon as I run that guy, it spikes. Looks like it's still drawing. Still drawing. Wow, it took longer to count to 1 million than I thought. Maybe I'll do 100,000. Do 100,000. Should be a little bit faster, right? Yep, there it is. It hit it. And you can see it go down. There you go, Roland. My guess is if you could time it out, do 100,000 divided by 60, whatever that is, that's seconds, and kind of count and see, is that how long it takes. All right, so you might be asking yourselves, well, gee, Mike, this is all fun and everything. What's it have to do with a class? Well, funny you should ask. Online, there's a document under Files called Online Java. And it's under Files. And on page 50-something, because I can't read that number without my glasses, 59, starts the talk about graphics programming. At the end, they say, now, with your newfound skills, make a house. Okay? So, what you have to do is create a program with a frame of your specifications. So it could be like, more of a landscape than just a square. That has a house on it. Got to have windows in there, maybe a door, sidewalk, nice pretty tree. Maybe we want the sun, right? Maybe we want a flower. Maybe we want a bird. Come on. Come on. No. Come on. Come draw me a better bird.
All right. So it has to be straight lines.
I don't care. Draw a bird. You said you could draw a better bird.
All right, you got.
It's a bird with a smiley face on it.
Oh, that's his little wing.
That's his wing. It looks like a smiley face. You guys want to grade him on this? Sure. Is that what you said?
Right,
it's a very, very fat
what else do
bird.
birds look
Just so
like?
you know, I know you can't see it yet, but it's a very fat bird.
It's a chicken. It's fine.
I think it's the fattest chicken I've ever seen in my life.
It's a Thanksgiving chicken.
It's a Thanksgiving chicken.
Turkey, I mean. I'm good at it. Okay. I don't know what birds look like. That's the issue here.
I'd put a beak on it, yeah. Otherwise, it looks like a flying couple circles.
There we go. It's a fat pigeon now.
There's no way it's getting off the ground because it's like this big around and its wings are like this big around. All right?
There we go.
Oh, the wings are bigger now. Now, you got to ask yourself,
God, I should be an art major.
whose bird do you actually want to draw, Jericho's or mine? Now, don't forget, we want to put our name on here. Put our name on the house and anything else you want. All right? Here's the deal. This is an exercise in the importance of planning. So I want you to think about it. If I go in and I start just drawing that, with all these commands that we have draw a line, we have draw a circle, draw a rounded rectangle, so on and so forth. And you haven't made a game plan, you're going to be putting a lot of time into it. All right? It's going to be a lot of time. Now, also, you don't have to make a house. I've had people like, man, I really don't want to do a house. Can I do a tank? Sure. I want to do an airplane. Sure. I want to do Spyro. That's my niece. My niece is like, can I do Spyro? And I said, sure. She's in the graduate program. No, that's my son. No, he can program a little bit, but not a lot. He does. He loves birds and stuff like that. His birds look suspiciously like mine, though, Jericho. So. Yeah. No, it's much better, but you can see that I influenced him with some of my creativeness in the beginning. So, yeah. He's pretty good. He's a much better artist than I am. You can draw a very complex house if you want, with like shingles and stuff like that. But here's the deal. It's about the planning. So how do I plan that out? What's the first thing I need to do? What am I going to draw it on? You're right. I want to draw it. But I should probably draw it on something special. No. What kind of paper? Why? Why not draw it on graph paper? Why do I want to draw it on graph paper? Because it's got coordinates. I can make coordinates. Now, my niece went out and taped together like 20 pieces of graph paper and drew out her freaking Spyro. I don't expect that. What could you do instead of buying enough graph paper and tying it together so you had every single coordinate? So let's say that this is a 1,000 by 500, right? That's 1,000 by 500. Let's scale it. Absolutely. Scale it down to one piece or maybe two pieces or three or four pieces, something like that. So after I've drawn it, I have to go through and I have to decide what the coordinates are. So this is going to be, you're going to say like square, and then you can put like, we'll say that's 250, 500, something like that. I'm sorry, 500, 250, right? And that would give me that square. So you go through and you figure all that out. How do I do the trees? Bunch of circles. By the way, that's called clipping. That's exactly how it's done in your games, is they use polygons to make everything up. If it's a 2D game, they use circles and squares and everything else, and they clip it. All right? So that I put a bunch of circles in, and the next thing you know, I got the top of a tree. All right? After I have done that, still planning, what do I need to do next? I want to pseudocode it. How am I going to pseudocode it? You're right. How am I going to pseudocode it? So you're going to come in and you're going to say, okay, here's my house, right? And you're going to say, well, I need a square that's at 500 by 250, which is 250 by 250 or whatever. And you're just going to go down and you're going to lay all that out. You're going to double check it. Then comes the real easy part, which is what? Code it. If you do this, the longest part is going to be reeling yourself in from your drawing. Because if you're creative and you enjoy doing that stuff, you're going to make this big, huge, fancy, elaborate picture. And that's fine. You can make it as fancy as you want. But you got to remember, you also got to go through and calculate all the coordinates. At the end of the day, if you understood everything we did today, and you pseudocode it, and you put it on some graph paper, you're looking at a 2 to 3 hour project. That's about it. If you just decide to jump into the code, you're first going to lose 50% of your grade because you're not going to have the pseudocode. because you have to take pictures of the pseudocode and submit it with the project. And second, the project's probably going to take you about 4 to 6 hours, because you're going to be like, oh, that's not where I wanted the house. Oh, no, I moved that part of the house. Now my windows are where they used to be. Now I got to move all the windows. Which one were my windows? Oh, there's my windows. I got to move the window over. So leave yourself plenty of comments in your code in case you do need to move something, so you know what the lines and the circles and the squares and everything else actually represent. I'll give you about, no, wait a second, your paper's due next week. I'll give you a week and a half. Nah, I'll give you 2 weeks to finish this. Now, I know some of you, you'll just dive right in, you'll get it done, and that's fine, but you got that paper due too. That paper's due a week from Sunday. Week from Sunday. So that makes this due the week before Thanksgiving.